Welcome to the Story Guide. Introduction. Have you ever wondered about the unseen forces that govern the transformations around us? From the rusting of iron to the burning of wood, these changes seem to defy logic. Yet, beneath the surface, a fundamental law of nature ensures that matter is neither created nor destroyed. This law, known as the law of conservation of mass, is the cornerstone of chemistry and explains the magic behind every chemical reaction. The law of conservation of mass. In essence, the law of conservation of mass states that the total mass of the reactants in a chemical reaction is equal to the total mass of the products. This means that the atoms involved in the reaction are simply rearranged, not created or destroyed. It's like a puzzle where the pieces are shuffled, but the total number of pieces remains the same. A closer look at chemical reactions. To understand how this law works, let's delve into the world of chemical reactions. A chemical reaction is a process where substances called reactants undergo a transformation to form new substances called products. This transformation involves the breaking and forming of chemical bonds between atoms. The role of atoms. Atoms are the building blocks of matter. They consist of a nucleus containing protons and neutrons, surrounded by a cloud of electrons. In a chemical reaction, atoms are not created or destroyed, they simply rearrange themselves to form new molecules. Balancing chemical equations. To illustrate the law of conservation of mass, chemists use balanced chemical equations. These equations show the reactants and products of a reaction, along with the number of atoms of each element involved. The equation is balanced when the number of atoms of each element is the same on both sides. Examples of conservation in action. Combustion. When a piece of wood burns, it combines with oxygen from the air to produce carbon dioxide and water vapor. The mass of the wood and oxygen before the reaction is equal to the mass of the carbon dioxide and water vapor produced. Rusting. Iron rusts when it reacts with oxygen and water to form iron oxide. The total mass of the iron, oxygen, and water before the reaction is equal to the mass of the iron oxide produced. Photosynthesis. Plants use sunlight, water, and carbon dioxide to produce glucose and oxygen through photosynthesis. The mass of the reactants is equal to the mass of the products. Applications of conservation of mass. The law of conservation of mass has numerous applications in various fields. Chemistry. Chemists use this law to balance chemical equations, predict the products of reactions, and calculate the amounts of reactants and products involved. Environmental science. Understanding conservation of mass helps scientists study pollution, climate change, and other environmental issues. Engineering. Engineers use this law to design and optimize chemical processes, such as those used in manufacturing and energy production. Limitations and considerations. While the law of conservation of mass is a fundamental principle, it's important to note that it has limitations. In nuclear reactions, mass can be converted into energy according to Einstein's famous equation, E=mc². However, in most everyday chemical reactions, the amount of mass converted to energy is negligible. Conclusion. The law of conservation of mass is a testament to the underlying order and beauty of the universe. It reminds us that matter, in all its forms, is eternal. By understanding this law, we can gain a deeper appreciation for the intricate workings of the natural world and the transformative power of chemical reactions.